Hi, good morning, my dear students. I'm Miss Daphne Khor. Welcome to my STPM Chemistry discussions. Spark brilliance, inspire life. Have you noticed that everything speeds up when it is hotter? Your phone battery drains faster, your process dry quicker. Chemistry works the same way. Some reactions act like they are late for class, some reactions move like they are fast asleep. This is because the temperature quietly controls how the molecule move and react. Today, we will connect this simple idea to reactions rate theory and see how this speed controller appear everywhere in our daily life.
Chemical reactions do not always occur at the same speed. Some reactions happen slowly, while others occur very quickly. The speed of reactions depends on several factors, including concentrations, temperature, catalytics, and surface area. In this experiment, we will investigate how temperature affects the rate of reactions by measuring the time taken for the solutions to turn blue-black. Let's first look at the apparatus and chemical required for this experiment. These are the apparatus used in this experiment, while the chemicals including potassium iodide solutions, starch solutions, sodium thiosulfate solutions, hydrogen peroxide solutions, and sulfuric acid. Before we go to the procedure, I would like to show you the flow of this experiment. We need to prepare two mixtures of solutions. For mixture 1, all the chemicals are mixed in a conical flux. For mixture 2, the chemicals are mixed separately in a beaker. Then, the solutions in the beaker is quickly poured into the conical flux, and the stopwatch is started simultaneously. The time taken for the solutions to turn blue-black is recorded. The experiment is repeated at different temperatures. Finally, a graph of 1/T against temperature is plotted. First, 25 cubic centimeter of potassium iodide solutions is transferred into conical flux using a pipette. Then, 10 cubic centimeter of starch solution is added, followed by 25 cubic centimeter of distilled water. Next, 10 cubic centimeter of sodium thiosulfate solution is added using a burette. The mixture remains colorless at this stage. Then the temperature of the solution is measured. This is the first mixture. For the second mixture, 50 cubic centimeter of hydrogen peroxide solutions and 20 cubic centimeter of sulfuric acid are added into a beaker. Then the solutions in the beaker is quickly poured into the conical flux, and the stopwatch is started simultaneously. The conical flux is thrown gently, and the time taken for the solutions to turn blue-black is located in table 1. The procedure is then repeated using different temperatures. To help you understand the calculations process more clearly, let's use 31 degrees Celsius as a sample calculations. For questions B, first, calculate the value of 1/T for each temperature. Next, plot a graph of 1/T against temperature. Temperature is placed on the x-axis, while 1/T is placed on the y-axis. Since reaction rate is proportional to 1/T, the ratio of the reaction rate can be calculated by dividing the two values.